So this is the last in the series of video-based lessons on linear programming applications in Chapter 14 of the textbook. On this last video will demonstrate the final sort of class of linear programming models, which are called multi-period financial planning models. And they're similar in structure but different in application when compared to the multi-period production planning models we discussed in the previous video. So these models are concerned with decisions on how much to invest in each investment option/opportunity to maximize the expected return while maintaining the required minimum cash balance typically. So the DA Branch and Sons is the fifth of a set of Chapter 14 models, the template for which is again contained within the reading subfolder of the 04 Applications folder. Although this is the final time I'm going to say this, I'm not going to go through the 8 Chapter 14 exercises in either videos or class. They are great examples you should do on your own as part of your chapter readings. So DA here is faced with a decision on how much to invest in each of the 3 CDs, each with different 1, 3, and 6 months maturities, with the objective of maximizing total cash at hand at the end of the planning horizon, while, of course, maintaining the minimum required cash balance, which is specified someplace. Okay, just like with the multi-period production models, it is often helpful to draw a chart of investment flows, since it makes it easier to visualize the cash flows and balances. In DA example, for each of the 6 months, there are given cash flows associated with the fund, some of which are outflows, expenses exceeding income, because you can see these arrows, 3 of which are outflows, 1, 2, 3, right? And 3 of which are inflows, 1, 2, 3 here, where the income exceeds expenses, right? All of which are sort of separate. These at the bottom from the CD investments we are sort of looking at in detail. So regarding the CDs, the cash flows are the decision variables on how much to invest in each one at different points in time. So the black arrows, but this time these guys over here, connecting all the months are amounts labeled with capital A, like A1 through A6. We want to invest in a 1-month CD for each of the 6 months. So these present us with 6 possible decisions. For the 3-month CDs, the decision is on how much to invest in each month, starting with month 1, okay, right here, the blue line, maturing in month 4, okay, then month 2 maturing in month 5, month 3 maturing in month 6, and finally month 4 maturing in month 7, the end of the planning horizon. So these present us with 4 possible decisions labeled B1, B2, B3, and B4. Finally, the last decision on how much to invest in a 6-month CD must be made in month 1, right, maturing in month 7, and that is the only C1 labeled variable. So this means that the total number of decision variables in this problem is 11, right? 6 1-month CD related decision variables, 4 for the 3-month CD, and 1 for that 6-month CD. The only constraints are that for each month the cash balance must be at least 10,000, which is specified someplace in the book. The graphical representation on this slide makes it relatively easy to identify the balance of cash inflows with outflows using the net of the amount on arrows coming in to the month node, right, versus the ones leaving it. So for example, month 4 here, okay, cash balance involves 3 inflows, right? That's 20,000 coming from that income greater than expenses. That income is not related to these CDs, right? Then A3 comes this way, and then B1 comes this way, and then there are 2 outflows, the investment in B4 and then investment in A4, right? So if the sum of inflows minus the sum of outflows is greater than or equal to 10,000, that minimum cash balance requirement is met. And again, the same goes for the other months. Please check out the details of this example in Chapter 14. It is a good one, especially if you're a finance major. Pages again 485 through 488. Only 3 pages. Our own model, representing the last hands-on example in this series of videos, is very similar to the one just discussed with a DA Branch and Sons. Okay, there are 5 investment opportunities with different returns and maturities as you'll see once you open the Excel file, and the minimum cash balance is simply to stay positive in each one of the months, so there's no $10,000 requirement. However, there is a cap of $75,000 on each individual investment, which we did not have with those CDs for the previous example of DA and Branch and Sons. So at this point, let us switch to the elect for MULTPRFIN plan. Right, these names are getting more nebulous for these examples, and let's just review the data piece real briefly. Right, so initial amount to invest, that maximum of 75,000, and interest rate on cash that we'll have to keep tabs on as well is shown at the top, and then there are cash outlays on the investment, okay, incurring at the beginning of the year. So in terms of in terms of dollars per amount invested, right? So for example, in year one, okay, the possible investment outlays are associated with investment opportunity A and C. So these are more abstract than the CDs we discussed for the previous example, right? In year two, there's only one investment and so forth, and you can see that it starts with year one and goes to year four. This is a 5-year sort of planning horizon, and returns materialize from years 2 through 4. As you can see, that's all going to balance out towards the bottom, right? Okay, so these are again on a dollar invested returns from investment A and C, then for investment B, and so forth and so on. Okay, so I'm going to scroll towards the bottom. I'm going to start by assuming we're going to invest $50,000, just making the number up that's in a sort of rough ballpark here, each year to establish a baseline for creating formulas, right? So 50,000, trying to not screw up these formatting borders, which is not easy. Okay, and then I'm going to reference the maximum per investment. Again, I don't have to do this again now 5 times for 5 different investments, but it makes it sort of easier to look at later on. Okay, and then what we're going to do is going year by year, the cash, we're going to sort of track the cash flow, right? So the cash invested at the beginning of year one is simply going to be the reference to that top cell B5 of 100 grand right here. Okay, nothing else. Okay, there are no returns in this cell right here. What is it? C31 from investments at the beginning of year one since we just started, right? So the cash invested though is a sum product of the investment decision cells and the cash outlay on investments in year one at the top of the model. So let me see what that means, right? So sum product, right, of these investment decision cells, using all 5, comma, and then these cash outlays on investments, which then sort of point out to the 50,000 here and 50,000 here, right, for the investments A and C, right? So, so the total then will be 100,000, and I am going to fix the row 11 so I can copy this later on. I'm not going to do it right now though. Okay, so then the cash investment, the cash after investment, I'm sorry, is the beginning cash, okay, plus any returns from investments, which we know we don't have any here, okay, and then minus the cash invested, during the year, right? So that's the cash after investing, which in this case is 0. But if it was, some positive amount, then the beginning of the next year cash would be not just a reference to the end of the previous year, so to speak, in those balancing constraints sense, but would also have to take into account, which is easily forgotten, and I did it the first time around, actual interest for not investing, all of the money essentially, right? Which is certainly a possibility. Right? In this case, we're hoping that, of course, the returns on our investments are more than the money market account, which I suppose this is supposed to represent, although 3% is kind of high for it at the current time, but it again needs to be in there, right? So the returns from the investments now, okay, is a similar sum product function, right? Okay, using the same sort of investment array B25 F25 with now the returns for that particular year, right? So this is matching year number 2, right? Which are the returns on those investments A, and B. And I now realized in the previous sum product I did not fix the correct rows. It should have been the row 25 with investment decisions that's fixed, rather than the row 11 up there with investment outlays, right? So I'm going to quickly correct that without losing too much time, and then copy this one down to get the $50,000, and then I'm going to just copy again that cash after investing formula, and in this case I have $35,000 in the ending cash, which will earn some interest as I okay, I screwed up this one as well. The dollar amount is here rather than there, right? So it's going to be more than just 35,000, 5% more, or 3% I should say more. And then I should be able to copy, right, this one down, right? I should have been able to copy all this down for year 4, really. Okay, but again, the last year is special. Again, a little different, right? Under the current scenario, right? We would start with 142,000, a little more in cash. Okay, we'll have the investment of, okay, we'll have the investment of 95,000, right? But there's no more cash invested because it's the end of the planning horizon, essentially, right? So the last 2 cells, the beginning cash for year 5, these last 2 cells, the beginning cash for year 5, and the returns from the investment, right, currently, right, are going to be maximized, right? We're going to be maximized as the final cash at the bottom here, right? So let's create that formula, adding the beginning of the last year plus return from investments flowing into that, currently about $237,000, right? So the solver will then try to maximize this final cash cell. Okay, again, I'm going to zoom in as I generally do at this point a little bit. So add in solver, maximize this cash flow by changing, all right, the investment decision cells right here. Okay, while keeping the minimum cash balancing requirement, which is right, minimum cash balancing requirement, which is just these guys being positive. Okay, the cash after investing has to be positive. Okay, not variable, so it's constraints. Okay, has to be positive. Okay, and then also we can't forget the bounds on the investments, which is that this needs to be under 75,000 over here. Okay, I believe that is it. Okay, the standard stuff here with the non-negative variables, and just remember we started with about $237,000. Let's see if this can improve that. Yep, not hell of a lot, but about $50,000 improvement by again, I'm not gonna look at that. I don't care about the insert sensitivity report at this point. It's sort of maxing out investments B, D, and E, as you can kind of tell. With the lower than the maximum investment for A, but not much, and then about half, a little less than half, of investment C. Turns out to be a better mix here. Okay, I'm going to save that example and switch back to the presentation. Right, so I did not go much, about this flow, but it sort of mimics those 2 data tables, where the investment A yields returns in a year later, and 2 years later. Investment C only 1 year later. B has a 1 year and a 2 year return, and then E and D are just 1 year returns. So kind of like those CDs. Okay. All right. So trekking to the end here. So this slide just discusses the remaining 3 examples from chapter 14. The templates for which again can be found in a reading subfolder, right, as well. I already referenced J&M, the middle one here, as an example of how to treat the models with bounded variables by introducing the auxiliary variables to get the bounded constraints explicitly into the sensitivity report. I also mentioned Walker-Wine's example at the bottom, where the sensitivity report was not as useful because the constraints cannot be related to their original intended form. Changes in the right hand side of one of the model constraints change other parameters used in other constraints and thus violate the basic principle of sensitivity reports, which is analyzing the impact of changes in a single parameter at a time. The last example is at the top of the slide. It's another investment model where issues with scaling are discussed in some detail, and I'm not going to do that at all. The main concern is that a poorly scaled model can result in incorrect optimal solutions, so we must think carefully about the units of scale of parameters in our linear programming models. Finally, the summary slide. In this series of videos, we introduced a number of generic linear programming models, as well as the set of standard linear constraints that appear in these models. We studied the characteristics of these models in an effort to improve our ability to model similar problems in the future. The rest of the slide describes the four types of models that, in addition to the basic product mix discussed in chapter 13, represent a decent cross-section of linear programming models that can be adopted to a number of different situations. Okay, we started with the process selection, make versus buy, transportation, multi-period production and finance model, and demonstrated how these can be built in a spreadsheet along with some process visualization with flowcharts and visualization of results with some basic Excel charts as well. Right. Next, we're going to go and work through a number of problems from the end of the chapter 14, right, to see how much of this we can put to practice, and then you'll be ready to work on some more on your own for the next assignment. Okay, the end.